All right, I'm going to do a quick video on those poker hand problems. Another video on those poker hand problems in the homework. I had handed out a sheet in class, and I just wanted to go ahead and finish that with you. Let me find my calculator. Well, there, I'll just use my phone. Okay, so this chart right here has all the possible poker hands you can get. This right here, that number right there came from taking the 52 cards in the deck and choosing 5. Okay, and the order didn't matter. So you, like, if you got an ace 2 3 4 5, that'd be the same as a 4 5 2 3 ace. So that's why it was a combination and not a permutation. Okay, that's where that 2,598,000 number came from. You don't really have to know how they got what they got in the chart, but I needed to make sure you understood that if you had a particular 5 card hand, five different cards, that hand would fit in only one of these categories. There's no overlap. Okay. All right. So if you're being asked to get the probability of getting a royal flush, you go to the royal flush number and you see there's 4 possible royal flush. That's one for each of the different suits is where that comes from. Out of the 2,598,960 possible hands. Okay. Now you would divide that. In my math lab, they were asking for it as a decimal, and most of the time it said rounded to 8 decimal places. 8960. Okay, so for instance, that would turn out to be 0 point, and then it had a whole bunch of zeros, 5 of them. 1, 2, 3, 4, 5 zeros. 1, 5, 4. Now my phone in one orientation stops there. My calculator actually goes to 9 places. So let me do that. 4, 5, 6, 7, 8, 9. Goes to 9 places. So it goes to 3 and then 9. And then I'm asked to round to 8. So if the number in the 9th spot is bigger than 5, you would round up. So your answer to that one, let me put it up here. 1, 5, and then you would round the 3 up to a 4. So that would be the probability of getting a royal flush. Okay. All right. So you do a similar thing for a 4 of a kind. Let me do it in a different color. For that one, there's 624 4 of a kind hands out of the total. So you would divide those two. 2598960. Okay, and I got, when I did it as a decimal, I got about 0.123 and then 2400. My calculator goes to 9 places, so I'm going to do that here, 0096, but it asked me to round to 8. So that means round to that spot, and see after it is a number bigger than 5. So when I round on that one, okay, I need 3 zeros. I would bump the 9 up to a 10. So that would bump that up to a 10. Okay, and then you get rid of that. Okay, so that would be the 4. That would be the 4 of a kind. Okay. All right, now 4 4s, I did that one right after 4 of a kind because they're kind of related. See, the chart told us how many 4 of a kind hands there would be. There would be 624 of them. But when you think about that, that could be all aces or all 2s or all 5s, etc. Okay? So I want it to be 4 4s. And a 4 is just one possible type of card out of the 13 others, ace all the way through king. So it's one type out of the 13. Okay. So if I want to know out of this 624 four-of-a-kind hands, if I divide that by, if I take the 624, let me do it down here. I'm running out of room. 4 fours is what I'm working on. If I take the 624 and I divide it by the 13 different card numbers, that tells me, oh, sorry, gotta get back into my calculator. So that tells me how many four-of-a-kind hands divided by 13 is 48. That means there's 48 of those 624 hands. There would be 48 of them that would be made out of 4 fours. They would have 4 fours in them, so some kind of 4 in each of these spots. And then it would have a 5th card that could be any one of the remaining 48 cards. Okay, so that's where that comes from. Now, that's not the answer to the question because I want the probability of getting 4 fours. So I'm going to take that 48 over this 2,598,960. I'm going to divide it. And I'm going to get 0.12340 zeros, 1, 8, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. Mine goes to that on my calculator. And then I'm asked to round to 8 places, though, in the text, which means I have to round to here. So my answer would be 8, 4 would be 7, and that would be my answer. Okay. All right, now, seeing how I did the 4 fours should help you figure out how to do the clubs flush because it's a similar concept. All right, so let's change to blue. So when we're doing this one, a clubs flush. So a flush means all of the same suit. So here's 5,108 hands that would be considered a flush. All right, now they might be all diamonds, or they might be all hearts, or they might be all spades, but we want is for them to be all clubs. But there's only 4 different suits. So if I divide that by 4, that'll tell me how many of the hands would be, divided by 4, how many of those hands would be clubs. Okay, there'd be 1,277 of them. So now you're going to take that and divide by the 2,598,960. 598,960. And that gives us about 0.1234913 5 8, 9, and I've got to round to 8. So that would be basically it. What I'd put in the calculator or in the computer would be this. Since what's after it is less than 5. All right, now the 4 fours and the clubs flush, those are the 2 hard ones. I think the others are pretty straightforward, but let's go ahead and do them to be complete. All right, let me see. Let me go to, what color haven't I used? I've used green. How about we go to purple? Okay. So for a flush or 1 pair, we just take the number of hands that are flushes together with the number of hands that would be 1 pair, which is a lot. 8, 2, 4, 0. And you can add those up to get how many hands are a flush or 1 pair, and then divide that by the total number of hands. 2,598,960. That's right. Okay. So we'll do that real quick. 108 plus 109, 8240, and then divide by the total. And you should be working this out and seeing. And it's going to be a pretty big probability. It's 0.4245344. That's 1, 2, 3, 4, 5, 6, 7. I have to round to the 8th, and it's really 2,9. So I'm going to round that up to a 3 right there. So that would be the flush or 1 pair would be this. Okay. All right. And then one last one, I'll just do it in black, is using that word not a four of a kind. Okay. So let's go back to the four of a kind one. So there were 624 hands that were four of a kind. All the rest of them would not be a four of a kind. So you have lots of options on how you do that. You could take the 624 from the total number of hands down here to find out how many outcomes fit that condition of not being a four of a kind. Okay. Let me make a little room here. Since we've already used it, I'm going to just erase this little portion so I have a little room to write. So one way to think about it is, well, these are the total number of possible hands. And I know that there are 624 that would be four of a kind hands. So I could subtract those. Clear that out. 259. I'm working it as you do. Minus 624. And that's going to give me 2,598,336. All right. And then I could take that number and divide it by the total number of hands. And it should be a pretty large percentage. 98960. And I get 0.9997599. That's 1, 2, 3, 4, 5, 6, 7. And then after that is a 0 followed by a 3. So that would be 0. So that would be the answer to not a four of a kind. Now notice I could have also gotten it by taking my answer to a four of a kind, or should have been able to do it by taking my answer for the probability of getting a four of a kind. Okay. Those should match up. Now, sometimes your round off error causes that to be different, but see that right there? Wait, this was it. This right here. If I take 1, I could have done 1 minus that, and I would get this. That gives you another way to do it. Okay. All right. So I just wanted to go through. That's similar to the other video I did on poker hands, but I passed this out in class and just didn't have time to do it. So I hope that helps.